To mute that music. Testing, testing. Alrighty. Can everybody hear me? Let's go ahead and do some. Um, do screen. Screen two. Yep, yep. Okay. Alrighty. Who's that? I can't see your name on my end. Let me make this bigger. Oh wait, let me go right here. Let's see. Let's see. Oh, I just got. I think L. No, we ain't. We just getting started right now. I'm gonna give it a little time for everybody to come in and just getting everything set up so we can get going. So let's see. Let's see. Give it a little moment. Give it a little moment. Basically, we're gonna be talking about the history of blockchain. Also, I forgot to talk about decentralized databases versus centralized databases. But I think everybody got the gist of it. I'm probably gonna drop another video talking about that specific thing, and also a couple other individual videos on TikTok, like little shorts to kind of sum it up and get it straight to the point. Because I think people like those more. It just kind of help them understand the little key points, and then you can put it together, as you keep going and learning. But yeah, so we basically today, excuse me, we're gonna be talking about the history of Bitcoin and the cryptograph movement, the cypherpunk movement, basically the the atmosphere, I guess you can say, because the cryptograph was a movement, but the cypherpunks was a movement that in itself, but the whole um, Bitcoin thing just kind of brought it to the forefront and made it, you know, what it is today and everything like that. But also, if y'all on TikTok, can y'all give me some give me some hearts, give me some hearts. Also, everybody, can y'all hear me? Let me see how this TikTok look on here. I'm still getting used to this live stuff and trying to figure out how everything work. But phone acting up. Well, trying to get all this stuff because I'm streaming on multiple platforms at one time. Give it a little time, let everybody come in, engage. Yeah, y'all. So my heart goal, I'm trying to get 50,000 hearts. You know what I'm saying? Go on, bump it up. We're gonna try to get it going so we can get more people in and get everything flowing. You know, the more people, the more hearts, the more people we can get involved in. And that way we can really get this going and start a movement without people understanding this technology and then building our own infrastructures and all that type of stuff. So we get these hearts up, we can get some more people in here, get the stuff flowing and stuff like that. Like I said, tonight, y'all, we're gonna try to get 50,000 hearts. You know, that's the goal. That's the goal. We're gonna try to get it up there. Let me read some of these comments. Uh, good evening, everybody. Yes, good evening. Tish, you said you can join the Discord. When you click on the Discord, so TikTok, that's one thing. Also, on TikTok, they be tripping. Like when you click on, they on all these social platforms, they have a little web browser they own. So when you click on the link in my bio, it's gonna open up their web browser, and it's gonna have the invite in it. What you want to do is you want to hit the top corner, depending on your phone, you want to hit the option, and then open the link in your own web on it, like the phone mobile web browser. So that way it'll direct you straight to it. But TikTok, they be tripping sometimes. It's just, yeah. Let's see. Do everybody hear everything? Can y'all hear me on here? Absolutely. Let's get it. Let's get it. Yeah, appreciate y'all showing support and stuff. Yeah, so if you can join the Discord, oh yeah, the Discord link is in my bio. That'll get you directly to the community, so that way you can get into the lessons and learn everything. And also you can get caught up. So I have all the videos saved in the YouTube, and also they post in the Discord too. So I have it set up where it posts on the Discord and saved on YouTube, so you can go back to it later and watch everything and get it, you know, taken in and get a real understanding of it and stuff. So that way you won't be, you know, behind or anything like that. But and then also with the courses, I mean with the lessons. Let me show y'all real quick. Well, I posted a video if you didn't get a chance to see it, but in the lessons you're gonna see a section where it has the the little lesson section, and you that's where you post all your assignments and all that type of stuff. And I'm not doing no kind of like grading or anything like that. We just gonna kind of discuss everything, and I'm gonna make sure everybody kind of get an understanding of it the best I can. I am going to be doing some kind of subscription and community support system or whatever, because it's going to be going for later on down the line. Anybody that want to support the community and get us, you know, going and stuff like that. And also we're going to be doing a experience system. So basically, I'm going to be adding that experience system tonight probably, and get a couple other things organized in the Discord. But the experience system, basically, when you fill out the lessons and you do all that type of stuff, you're gonna get an experience rating basically. So that gives gives you an understanding like, hey, this what I done in the community, and this is what I learned, and you know, you kind of get like badges basically, you know, badges of honor and all that type of stuff. So let's see. Appreciate y'all for the hearts, getting those hearts up. Thank y'all, thank y'all. Yes, yes, y'all share everything, you know, share it with your friends and family and stuff. But let's go ahead and get everything going. I think get about 5 minutes, about 10 minutes, you know. But all right, so today basically what we're gonna be doing is learning the history, and I'm pretty sure a lot of y'all were familiar with the whole banking industry situation back in the day, where people was losing money in the bank, and it, you know, it was a lot of turmoil and all that type of stuff. There was a certain atmosphere that helped Satoshi basically flourish in the Bitcoin and all that type of stuff. A lot of people think it's dealing with the dark web, and that's how they was able to, you know, get Bitcoin popular and all that type of stuff. That was a part of it, but it wasn't the main aspect of it. It actually started a long time ago. If y'all familiar with, let me show y'all a simple cryptograph. Most people familiar with it. Um, I think it's cryptography. Yeah, yeah, we just say cryptograph. It might be cryptograph. Nah, I think it's cryptic. Let's see. Well, that's the root. Yeah, that's the root meaning of the word. That part. Yeah. So the root word of cryptic is cryptine, which means to hide. So that's what cryptograph, the beginning of it, represents. So you're basically doing a. Let's see. What is that? Let's see. Crypto. No, it was another one I had on another website. Don't forget, it's simple. I just type in. Okay, where did mouse go? Sorry, y'all. I got 4 screens over here. This might be moving all kind of places. Okay, what's going on? What happened to my mouse? Okay, sorry, my bad. We're having a little technical issues. Okay, root of cryptic and examples. Yeah. So basically, it's it's like a hidden meaning, so you can hide stuff in like words and numbers and all that type of stuff. So basically, it's a simple thing like when people put one. Let me see if they got an image of it. I don't know. Cryptic examples. So it's like, let's see what they got. Some it's crossword puzzles. No, I don't do no cryptic crossword puzzle. It's trying simple. Basically, it's like you putting a number for every alphabet. Like if it's one is A, two is B, or B is C, or B is three, and all so forth and so forth. So basically, you can just write the numbers down and send a message to somebody. Basically, it's a hidden message in it. But when it comes to the cryptograph, that's more complex, way more complex. So let me see. I can't find. I should have had an example ahead of time to kind of break it down more simpler fashion. But we just gonna get back to the topic of the main focus of it. So, uh, why my computer running so slow? Types of hash algorithms. Yeah. So on the first lesson, we kind of went a little bit over these hash algorithms. We didn't go over them really. We just kind of basically talked about what they, like what they kind of represent inside the block. So, but the hash algorithm is really it's the same thing what I explained with the simple, putting numbers and letters together to spread out a certain hidden message or meaning or anything like that. But the difference or the more advanced level is dealing with these mathematical equations or putting algebra and all other types of things in it. Like for instance, when you deal with computers, there's an aspect of it where it's a bit. So I'm pretty sure you probably heard things like 32-bit or 80 or x86-bit or 64-bit or whatever, and all that type of stuff. Those bits represent the data, the size of data in a computer. So it's small little bits, and this is kind of part of what they work with when they're doing the hashes. So computers, they don't obviously communicate how we communicate. We communicate by talking to people and just facial expressions and hand movements and all type of things like that. But computers, they speak to each other based on code or really is ones and zeros. The code is one aspect of it, but when it gets compiled or is deployed, it's read into a fashion of ones and zeros. So it's really just like a computer. Computers only can read in ones and zeros, but when we program it, it goes down into that when it's compiled or different aspects of coding and then converting it to a format where a computer can actually understand it. So that's what the blockchain does with the aspect of the hash. The hash part, it creates the mathematical equation dealing with the bits to create a more complex crypto or cryptograph basically. And it's harder for a human being to actually do the math to figure out this equation in one lifetime. Basically, you take multiple lifetimes to try to figure out this hash or this random string of numbers or letters and things like that. I showed you guys on the first one. Let's see, what's that blockchain? Make sure. So this right here was how hash comes out, and this right here is a SHA-256 hash. But like the example I showed earlier, if you type anything in here, it's going to automatically change this hash. So how they programmed it. Let me see. I don't think you probably got it. No, yeah, I ain't really go through that process. But they programmed it where it generates out a certain hash based on the let me show you real quick. Did that open up? Yeah, so hash algorithm types and methodologies and usages. So yeah. Where is it at? Did I have that up already? Yeah, okay, here it goes. So a hash a hashing algorithm is a mathematical function that garbage data and makes it unreadable. Or my bad, gargles data and makes it unreadable. Forgive me, mouth dried in the mud. So hashing algorithms are one-way programs, so the text can't be unscrambled and decoded by anyone. And like I said, it's a cryptic graph or cryptic message that basically, and it's done through mathematical equations where like I said, one human being, you cannot figure out this. You know, that's one of the things with the quantum computers. The quantum computers, the same way how a nonce, you can run up the different nonce and change the cryptographic hash on the second block. When you can change this crypto, you know, this you change this. Let's make that. So you change this number and it changes the cryptograph or the hash. I mean, and this right here, when it changes this hash, this is how you try to sit there and hold on, let me show you. Okay, yeah. This is the mathematical equation part. So when it pushes that out, let me put this over here so I don't keep jumping back and missing the page. So when it pushes those out, basically, when it pushes out this hash, it's the mathematical equation, and the nonce controls it, so that way you can sit there and it's more detail with it with the mining, but that way they can try to figure out what is actually going on or try to figure out the different tries. But the quantum computing, it would, like, if I did it myself, like 1, 2, 3, it would take me forever to do this. But with quantum computing, it would try to run. It can run simultaneously multiple different aspects or different hypotheses or possibilities, basically, in a short amount of time. And that's the thing about the quantum. But it's not really there yet. They're trying to get it to that point. But with a quantum computer, it can run the different algorithms to try to figure out, or the mathematical equations to try to figure out what that hash is. That first part where it said, oh, yeah, so hashing algorithms are one-way programs. So the text cannot be unscrambled and decoded by anyone. But with a quantum computer, it will be able to be decoded and unscrambled, because to try a million different options, like for instance with the, where is that? So when it's trying to find a number, it would take me forever to type in 10,000 or 108,000, you know, something, whatever. It'll take me forever to literally try to go through that process, you know, and doing that all day. But a computer can do it faster than us, way faster. So that's the aspect of dealing with the cryptograph or the hash and what it's trying to figure out. This is also the security aspect of it, because no one can actually, you can try to run, you can try to run and some scripts or whatever to do some things to try it, but I mean, you're going to be doing it forever. You know, it's really not viable in a human being's lifetime to try to participate in that or to make that happen. So this is the aspect of where it holds a lot of security in it. But let me make sure I go over this real quick. So what is a hashing algorithm? Dozens of different hashing algorithms exist, and they all work a little different. But in each one, people type in data and the programs alter it to a different form. So as you've seen with that first demo, whatever you put in here, it's going to take the data and hash out this right here. It takes the data and converts it. It does that with a mathematical equation. And then also with a uniform aspect and consistency in one way. So the one-way transfer where you can't revert back to it or reverse it and things like that. But let me make sure I read all these for y'all so y'all really get an understanding of it. And also you want to read these for yourself too, you know. But mathematical, strict rules underline the work an algorithm does. And those rules cannot be broken or adjusted. So once you code it in, that's the algorithm and it cannot be adjusted. And these, where is it at? No, type consensus, but type of hashes. Yeah, there you go. Why did it do it? Yeah. So these right here are all different types of hashes. Now we can go into these, and I really ain't trying to do all that, be honest with you, because it's a lot of complexity to it, and I'm not the best at it, and I don't profess to be the best at it. I just know a little bit about it and understanding it because I have to deal with it when I build websites and doing certain, when I was dealing with certain back end and PHP and all that type of stuff. You have to deal with it with data and people password and all that type of stuff. Like when I first started building websites, that was when I was kind of messing with it, but I ain't really dig into it too much because I just ain't really good with the mathematics and all the algebra and all that type of stuff. But I do use it, you know, because they have little services and systems, so you can actually type in any one of these and actually call a generator. So and they have little toolkits or whatever that we use where you can generate, type in whatever data, and it's going to output out a hash. So it's kind of a way of helping, do certain things or whatever. And when you're using tools and little programming language and stuff like that. But let's not get off task real quick. I want to make sure I stay on task tonight, so everybody get a good underlining of the information. So, all right, before I go too more detail into it, I want to give y'all the history aspect of it and the background of how everybody kind of, or the environment, what I said earlier, what was going on, because this kind of created, it was leading up to this, which created the blockchain, basically.
Not a monolithic
this right here. And also, I want y'all to watch this documentary. You don't got to really watch the whole thing because it's not, I'm not a philosopher of the technology. I'm not here to, preach the gospel of blockchain and cryptograph and all that type of stuff. You have people that do that, and I'm not one of them. I like to learn stuff to implement it. I'm more of a doer. So you got to understand stuff, and then you kind of, can do it and get things moving and stuff. Not to say these people weren't and all that type of stuff, but I prefer not to get too much into philosophy and all that type of stuff and the history and all that stuff. But this right here, it gives you a little bit of the understanding and the environment that was going on dealing with the cryptograph or the cypherpunks and how cryptograph basically formed and everything. We ain't gonna go through this whole thing. It's just gonna be this first little piece in this little history, and y'all can go, on your own and watch the whole thing if you want to get more deep into it. But every one of these aspects that I'm talking about, people take hold of it or they grasp it, and they actually become efficient in it and professionals in it, and they get paid and hired for jobs and things like that. So this, whatever one of these things kind of click with you, whether it's setting up a node, because I'm gonna talk about those a little bit, or doing cryptographics, or all that type of stuff. These different little pieces all have a possibility of setting up or getting a career in it, because if you learn it and you dig down into it and really get a hands-on understanding of it, you can get paid for this stuff. And one thing I'm gonna show y'all, so GitHub, because I know a lot of people be trying to get into tech and stuff like that. If you can actually do the code, a lot of people, you can get opportunities, and there's a lot of other things I'm gonna show people where if you go through just even like GitHub, or not GitHub, but like major companies like OpenAI, um, any company really, a lot of them, they have like interns and internships and all type of little things where you can just kind of get your foot in the door. And if you know some of the stuff, you really dug down deep into it and try to learn the technology or in a specific aspect like cryptograph, or I just want to learn how nodes work and how I can set them up and master that and be more efficient in it and expand the technology. When you get into that, people recognize it, and this is where you put your code at. So you will basically upload all your code. So GitHub is a repository. It's a place where developers upload their code and share the different projects and things they're working on, and also sell products and all that type of stuff. I use a lot of it, to see what's going on new and play around with stuff. And also myself, when I develop things, I put it on here and stuff. But also a lot of things, give y'all a little heads up. A lot of services y'all pay for. You know what I'm saying? If you learn how to do the coding, you can actually get a couple of them services for free. People make things like they have like let me see some ones I started or whatever. Have like when you're doing like let's see where it said. It was one I was messing with. Well, I know for sure DeepSeek. So if you want to do a large language model and run your own little AI thing, you can do that there. It was one like if you're using like the services where you schedule posts. So when you schedule and post, or you scheduling content and things like that, or making content or things like that, you can basically what they call is clone the repository on your computer and basically launch whatever software that they have built, and they actually give you step by step how to do the stuff. So let me see. This one right here is UI screen to okay, so I think it's a screenshot to prompt. So this right here is basically you take a screenshot UI screen to prompt, and it'll turn it to a prompt for you to put into ChatGPT and generate the actual layout of the website or whatever you're doing. But you see, they give you instructions. Like all these things give you instructions. They break down how to set it up, clone a repository on your computer. You have to do something depending on what languages. If it's Python, that's a little bit more complex, and you got to set up an environment and everything like that. But with the other ones like reacting and simple ones, it's kind of, it's not really complex. But I also did sometimes with a Docker. But I'm gonna make a video about that and kind of explain that stuff. But yeah, if you want to get into tech, this is something you definitely want to start. You want to start a GitHub so you can start teaching, or not teaching, but learning for yourself, and also showing what you learned by posting it in your GitHub account, and then you can share it with people and all that type of stuff. And also collaborators. That's how a lot of people come together and build and collaborate. I'm actually going to be setting up a community for us to do some of the coding stuff, and so you guys can download it, and we're going to go over the whole process of how this stuff works, so you can actually code your own stuff and build almost anything you want. And especially with AI, you can actually, AI helping out with a lot of that stuff. So you can actually type in what you want, and it's going to basically generate it for you. So, yeah. But all right, so let me get back to this cypherpunk. So this right here is a quick intro and a breakdown of a little bit of the history. We want to get into this. So let's hit this.
Thing which is your enemy. It's a multitudinous thing which is your enemy.
Our dream was to...
Hold on, let me get me off of here real quick so y'all can see it. Maybe I should. I probably shouldn't make it full screen. Hold on. Because I don't want them to take this video down. Well, they probably won't. They probably ain't gonna say nothing about it.
Government is not a monolithic thing which is your enemy. It's a multitudinous thing which is your enemy.
Sorry for the lag, y'all. Appreciate y'all for the likes. Good looking out. Good looking out. Thank y'all. Thank y'all. Let's try to get to that 50,000, y'all. Let's try to get that 50,000. I appreciate everybody's giving likes and gifts and everything like that to support. Thank you. Thank you.
Our dream was to enable the future of human freedom.
In the early 19...
Why is my loading so slow? I probably got too much stuff going.
1990s, a group of mathematicians, misfits, hackers, and hobbyists came together around a shared belief that the internet would either
Oh my God. Okay, I don't know why this one taking forever to load up. Let me find this another one I had seen.
either demolish artificial walls or lay the groundwork for an Orwellian state.
We can prevent the ministry of truth.
This won't work right. Okay, this mug tripping. Yeah, alright. So y'all probably got to watch it on y'all own. I'm doing too much stuff right now. I got the streaming going, got Discord, and I'm streaming on YouTube in here.
They saw a branch of mathematics called
Yeah, this ain't gonna run.
cryptography as a weapon against central planning and surveillance in this new virtual world.
And what is a cypherpunk? Cypherpunks are cryptography activists.
The more I realized how it was a really pivotal technology for society.
The National Security Agency declared
spoke too soon, boy. I spoke too soon, boy. Too much going on.
The unrestrained public discussion of cryptographic research threatened our national security.
I saw this as the critical fork in the road for the future of human freedom.
Coming up, Reason presents a 4-part series on a movement that foresaw both the promise and the peril that lay ahead when the internet upended the world.
It's like standing on top of the mountain and seeing that this is out there.
You people who are here can say, okay, what kind of world do we really want to build, and build it.
Imagine, if you will,
Okay, forget it. We're gonna do the spoken version. Let me keep waiting for this video to load and all this crazy stuff. Alright, so basically, to sum it up, what happened with them, it was a lot of, well, it was particularly one guy that kind of started majority of this stuff. I think it was called Amex or something like that, American Information System or something like that, where they was sending data. So they was kind of the start of when websites and what they call those, the internet was first coming out, and e-commerce websites was coming out, and everything was going, and the understanding of the technology, people was trying to, let's see, it was certain people that basically seen where it was going or where it could go. So they was trying to set up certain, where did they go? What is this? You got some video game? You know I'm old. Cyberpunk. Other than Cyberpunk blockchain. This is obviously a video game, something. A movie, anime. Oh, now I can't even find the video no more. Forget it. So basically, there were two people, or two groups basically, that talked about certain aspects of cryptograph and protecting information and or like Orwellian states and all that type of stuff, dealing with certain philosophy. It was what was that guy? So it was an individual, I can't remember his name, but he represented a certain belief to protect everybody vote, or protect everybody right to vote, or voice their opinion in certain situations. So it started from an individual that talked about okay, never mind. Let me go back to my history and find that one video, so you can really understand the detail of it. Okay, yeah, this here you go.
And put on
this the show.
The power of your
Government is not a monolithic thing which is your enemy. It's a multitudinous thing which is your enemy.
Our dream was to enable the future of human freedom.
In the early 1990s, a group of mathematicians, misfits, hackers, and
Okay, yeah, it ain't working no way. No way. Sorry, I see. But yeah, when y'all get a chance, watch that video. Watch the little, this is really just the first point in the history, so you can see the atmosphere of what everybody was basically fighting, or it basically had two different dynamics in a sense, where certain people were trying to save certain freedoms and rights of things, and some people was trying to use it for nefarious deeds and things like that. But the cryptograph community or cypherpunk community was basically focused around cryptograph and hacking stuff and all that type of stuff. But that atmosphere led up to another atmosphere when they was talking about the banks and how the banks were taking over.
Hobbyists came together around a shared belief that the internet would either...
I should have downloaded this video. That's what I should have did, so I don't have to worry about that. But yeah, so anyway. But yeah. Oh, let me see if I can find that one poor old boy. Oh, never mind, that's already closed out. But yeah, so it was one guy that started the Amex port, but then he died in 91 or something like that, or 92 before. This is right when the internet first came online. So he died when the internet first came online. And his work basically set the foundation of a lot of e-commerce systems and cryptographing and passwords and saving information to protect people and things like that. So it was a discussion back then where if I send something to somebody, how do we protect that information, or how do we, like it was always a one-way send of data, but now it's like two-way sends backs of data, and that kind of that leads to things like dealing with when you see on your social media, if somebody send you a message, then you can see if they read it or not. You know, that's the two-way back of data that all this stuff was kind of built on, and he was the one that kind of started it, but he built the whole little system. And that was really the forefront of dealing with the crypto. I won't say the forefront, but that was the atmosphere where everybody was at when that was going on and stuff. But then later on, when you come down to the aspect of Satoshi and what he was trying to do, that. So let me see, the Satoshi aspect of it. Let's see, where is that? Oh no, I forgot the crypto. Yeah. Okay, yeah, here we go. So this right here, I'll show you. Hold on, let me get that. But you can read this on what you got. Yeah, so I'm gonna put that in the chat too. Oh dang, my bad. Sorry about that, y'all. My fault. I had the mic muted on the Discord. My fault, y'all. I thought it was going through both of them. But what I was saying, basically the history with the young what's up, boy? I can't remember the guy's name, but he basically started the whole Amex aspect and kicked off the whole system that basically protected sending data and all that type of stuff, and basically kind of the foundation of how it was sent off. But what I was getting to right here with, where is that? Yeah, so cryptographer, yeah, Dave Chung was the first proposed the blockchain-like protocol in 1982. So, where is it? I don't think I got that Amex guy. And also the hash cash. So that's something else you really want to look into. What was it? It's called American something. American data something, transfer or something. I don't even want to mess it up. Forget it. There's something, but basically just look that up when y'all get a chance, because that was the start of it. And then, like I said, the environment that kind of created the environment of what everybody was feeling back then, which created the things that built on top of the cryptograph community and the whole cyberpunk movement and stuff. But with the Bitcoin, so Satoshi Nakamoto, so Satoshi Nakamoto, he was the he was the individual that basically solved the Byzantine problem, where it's at, or what they refer to as the Byzantine fault. So this right here, this port, and the Byzantine fault, I mentioned that yesterday. So if you have a target you're trying to attack, and if everybody coordinates with the same plan, then the attack will be successful. But if you have people that want to quit or don't, or the traitors or whatever it may be, obviously the plan won't. Obviously the plan, it won't succeed or whatever. But to get more deep into how that whole concept, like for instance, if you have, say if you send everybody a message, so this person right here, this is the general, right? And I want to send a message to all these people, to get, one, a response to them, or basically one, send a message to them. Two, you want a response back from them. And then three, it's an aspect of it. If is the response an actual real response from the people that you sent it to? So say if I send a message to him and when this person's coming back, they get attacked or whatever, and these people become a spy, or put a spy out there and send that information back to give them misinformation. That's part like the hacking aspect of it. And this is what the whole Byzantine aspect of how do you solve that? How do I send a message amongst my parties or people involved and get a real answer back and make sure it's not misleading or hacked or it's not intercepted or anything like that. So that's the whole Byzantine fault thing in a nutshell, basically. But this part right here, if everybody works together, then it's successful and everybody's attacked or whatever, or everything happens out, But if they don't, then you fail, and obviously you lose resources, or the attack don't work, or whatever it may be that you're trying to get a consensus or agreement on. Now that's the whole aspect with the Byzantine fault, and that was the issue. So what Satoshi came up with was the whole blockchain and the distributed ledger aspect of it. So the distributed ledger, when we mentioned yesterday, talking about how the hashes connect one another. So once a hash is in one block, then the next block that goes after that has the previous hash or previous block hash, which then creates a link. So and once it's created and someone else downloads that on their node, then multiple people have that. So go back to that Byzantine. So if multiple people have the So if multiple people have the same ledger and then the message is sent out, or the block is created, that's the consensus aspect of it. When the block is created and everybody has that on the ledger, then no one, like this person right here, can say, I'm gonna change this so I can make some more money, or do some kind of fraudulent stuff or whatever, because everybody has the ledger. Everybody literally has the whole blockchain ledger. Hold on, let me see that, because I don't know, what's that? Where is it? Okay, yeah. So everybody has this ledger. So this right here is the distributed blockchain. So peer 1 or peer A, peer B, peer C, peer D, E, B, C, so forth or whatever. I mean, A, B, C, D, E, F, G, F, all that. So forth. Every peer, every person, basically, that's what a peer is. Every person has this whole ledger. So nobody can come over here and do this. And then now if you see, this right here is the only one messed up. So if somebody came and changed or added some data or took some out of it or whatever, they would have to remine this whole block, and everybody would have to. It will be that's like that doesn't happen or whatever. But because it takes it's too. So anytime, and this is the whole point with the cryptocurrency part. That's the key point. When money is put on it. So if say somebody messed up this back here and sent something to somebody else, the wrong person, or the bishop sent it to the wrong person, right? This coin right here, the mining does the reward, and also it's a form of security, because if on this other block, the distributed one, if somebody does something back here on this one right here, to remine all these blocks, or remine the whole blockchain, everybody else to download it, they have to pay. So that's where the gas fee come in. So when you see, okay, they have to pay gas fee for this transaction, every time something happens on the blockchain, it spends cryptocurrency. The cryptocurrency moves the blockchain, and it's the gas fee. So every time a transaction is made, well, that one slide that I had, I don't even got that no more. Never mind. But every time a transaction is made, that one slide I showed yesterday where the transaction is made, and then the people do the come together to create the block, and then they verify it and stuff. Once they verify it and it's stuck on the block, that costs the gas, that costs the cryptocurrency, that whole process. But then that's stored in the main contract or the main blockchain when it first starts out. Like with Bitcoin, it was 21,000 or 21 million, I believe, Bitcoins when it first started out. So at a certain point, those Bitcoins are going to run out. Now that doesn't mean, and that's running out in the main contract. That doesn't mean that that Bitcoin or Bitcoin is going to stop running. When that main aspect of Bitcoins run out, the whole, what they call it, because it's a scarcity aspect of it. But the full amount of what they have in Bitcoin, the 21,000 Bitcoins, once that goes out and it's on all of it's on the block, it's no more held into that one contract. It's all on the block and being used or whatever. Then every time somebody has some Bitcoin, that value of that Bitcoin is going to be more higher because can't no more Bitcoin be basically mined no more. So anytime when somebody does a proof of work and how the Bitcoin blockchain work, when they do proof of works or whatever, they mine the Bitcoin and that's how they get rewarded. So how this works, this is how when somebody changes back here, all these blocks, all these people ledgers, A, B, C, D, E, F, G, all these people ledgers are still the same. This person ledger was wrong. Well, this person block was wrong. But then when say they try to verify it, that like for instance, if you are validated and you did something like that, that's automatically kick out. Because you can't do it because you have to go back with all that money that's being spent. You have to use all that computing power to do that, and that's gonna take forever because you have to go through every one of these hashes right here. The same way how a person does the computing power to hash out, to figure out the hash equation, to find out what the hash is, they will have to do that in reverse. And that's the whole point of the security aspect of it and it being linked to one another. So that's a very important aspect to understand when you're dealing with the blockchain and how it's secure and how people can't, like a lot of people, they don't understand that aspect of it, that every time a transaction is made, there's money being spent and it's going forward. So in order, it's compute power being spent and it's money being spent. So in order for it to go back, to reverse it, it's the same thing of figuring out the hashes. And you can't because the hashes are one way. The only way, like I said, that with the computation power or quantum computing, quantum computing can run 1 million different possibilities in a split second. That's the whole idea and the theory behind it, and the goal is what they get into. And if you only have 5,000 possibilities in something, in an equation or whatever, right? They solve that it's only 5,000 options. The quantum computer can figure out that in no time. So then boom, now they unlock that whole hash. So now they know what the hash is. But with the blockchain, it will still have to go through every last one of these hashes to figure it out. And that's the main thing about what makes it secure, what makes it the blockchain, and that's what the Satoshi Nakamoto aspect of what he basically solved in a sense. But the proof of stake is just one of the consensus. So it's multiple different, or proof of stake and proof of work. So it's multiple different forms of consensus, but really all these are based off of these two. Like the proof of delegation is basically they delegate certain tokens or whatever, and it's like I believe that's the one where you have who has the most tokens or something like that, dealing with that. Like the capacity one, that's I believe that's the capacity with the computer. So yeah, let's see, proof of capacity, is a consensus mechanism used in the blockchain network to validate transactions. And what's the it cut off right where the good port is. Oh my God, we know all the whole details. Okay, delegated proof. No, that's the delegated. Yeah. Then they also got proof of burn. Proof of burn is you basically burning your crypto. It's like you staking the cryptocurrency, and it's a form of burning your basic currency, cryptocurrency, and that's how you kind of get chosen in a sense. But it's I'm still kind of understanding how a lot of these work, but they all vary because people are trying to figure out, and that's why I say Satoshi did the foundation of it with the proof of work. They kind of run the whole theory and the idea, and people use Bitcoin and they understand the scarcity of it and how it can, how the security of it and all that aspect of it. But it's certain aspects where things can be done with it. Like with Ethereum, you can put smart contracts on it. So we don't even need to type that in. But basically, so Bitcoin, you can't program onto that. you can't add any code to to it other than the validation ports and the nodes validating transactions and things like that. You can't do any of the just that the certain aspects of dealing with smart contracts. So, and also Bitcoin only has one layer. There's people trying to like it's a whole nother people building on top of the Bitcoin layer. I think it was the light Bitcoin or something, or it's one of them they trying to build on top of it with, or they are probably already was doing this stuff, already did it, but it still cannot be, they cannot alter the regular Bitcoin code or whatever. But now with Ethereum and whatever and other Bitcoins like Solana, Near, all of them, a lot of them, Polygon, they have different layers, and they also have what they call them, because what's the Aurora? It's one. So with Near, they have Aurora. It's like a side chain. So it's like a blockchain, and then they built another blockchain on side that blockchain called a side chain. And this blockchain has more of a certain issues or whatever. So then they basically make, like, for instance, one of the issues with I think it was Ethereum, where it was costing too much for certain aspects of it. So what they did was they made a side chain where you can do transactions, and it's still, you can connect it to the Ethereum blockchain, but the side chain is cheaper. So it's certain, because once you spend so much on the blockchain, it gets bigger and bigger, and the computation and the cost and all that type of stuff get bigger and bigger. So certain data and all that type of stuff, it has to be moved around, and certain things have to be moved around. It's all kind of things they're trying to figure out and solve, and that's really the main equation dealing with all these different proofs of proof of work and proof of stake, or basically the consensus, the blockchain consensus. So that's what the mechanism, or the consensus mechanism, is all about, is trying to figure out a best way to implement this in the world, not only just on the Bitcoin where we just spend that money. You can't really put nothing on Bitcoin. So that's one of the issues with Bitcoin. You only can put smart contracts and layers on these other blockchains. But even Ethereum, Polygon, a lot of them are what they refer to as a fork. So basically they forked the Bitcoin blockchain, the code that was in the GitHub, where I showed y'all earlier, the GitHub website. The Bitcoin code is in there, and they basically forked that. So they basically copied the whole code and built on top of that. So a lot of these blockchains, they're basically Bitcoin, but it's just, they have to take that code and rebuild it, because you can't, once the block is built or whatever, like I said, that's the immutability of it, because Satoshi coded in there that you cannot put any smart contracts in certain aspects of how it works. You only can be on the blockchain for Bitcoin is Bitcoin. You can't put a token on there. You can't put anything else on there but just the Bitcoin. So that's the kind of dilemma with all these different consensus mechanisms come into place. They're trying to figure out a way to basically come to agreement to how to make blocks and how it should be made, and it's a lot to it. So it's and also a lot of these blockchains or these consensus mechanisms are used for different industries and different systems or whatever. Like I think it's proof of authority. It was I think that's the private one. So that deals with more of a private blockchain, I believe. Yeah, I think that's the one with that one. So yeah, but we not really, like I said, we not really gonna get too much into the hashes or whatever, the algorithms and the block mechanisms. We just want to use ones that work. When I do the lessons and teaching all that type of stuff, we probably gonna use like Polygon or Near or even Solana, because I know a lot of people use Solana. We basically just gonna go on the developing end and deploy some contracts on the test network so y'all can see how it works. So on a central database, when you're coding something, you use the IDE like Xcode or Android Studio or VS Code or this new one they got, Cursor. And IDE is basically the place where you code things or whatever. Let me show you real quick. So this right here is the Cursor IDE, and this is what I'm working on with one of my websites with Support Buying Black. But this is an IDE where basically you do all the coding and things like that. But you have to, it's an aspect of it where you come down here and you do the build of it. So npm or no package manager or run build or whatever. And when you do that, it basically puts the code, remember I told y'all, into a computer format where the computer can read it with the ones and zeros. And with the blockchain, it's the same kind of way. But you're basically, the block, once it's being used or whatever and mined and all that type of stuff and blocks are being made, that's when it's constantly building. But in order for you to get onto that block or get your data onto that block, it'll be building or whatever, and then you deploy a contract on there and say this block 10,700 or whatever, your smart contract is on that block, but it's always constantly moving. But you'll be able to access that data through the smart contract, but it has to be deployed on there. So, but now that smart contract can't be taken off of there, and it's certain aspects of it where you can alter it with the Ethereum and the other ones, but like I said, Bitcoin, you can't add any of that stuff on there. But we're gonna get into dealing with how we do that and deploy a contract to the blockchain and create some little small systems. But let me see what else we have to finish on and get onto the. So we got a associate aspect of it. Talked about the Ethereum, I mean, with the smart contracts and how you can program it. Kind of mentioned about it. But like I said, we're gonna do a real tutorial later on down the line, actually how to do it. Let's see what else. And also, yeah, we talked about the cryptograph aspect of it and the consensus. So this, I think that was everything for. Yeah. Oh yeah, that's one thing I wanted to forget. I forgot in my notes. So energy use. Energy is very important. That's also another thing. Excuse me. It's also another thing dealing with these consensus mechanisms. Some of them cost more energy than others, and that's one of the things that they're trying to figure out. So it's all kind of aspects of when you're using these different blockchains of the longevity of it, because some of them aren't feasible because of certain energy aspects of it. So if you build something and you put it on a blockchain that's going to eventually people are going to stop spending cryptocurrency on it, then that means that blockchain dies. And that's something that, another thing, if long as people are spending cryptocurrency on that blockchain, long as transactions are being made on that blockchain, the block continuously grows. It's just constantly ticking. It's really like somebody, I was in one of my courses or whatever, and the teacher had mentioned that the blockchain is like a time or a clock or whatever. It's constantly making, transactions, which constantly makes the blocks. And every block has a timestamp on it. So for instance, long as cryptocurrency is being used, it creates the transactions and then it creates the blocks. Whether you're using the cryptocurrency to buy something that you like, say you buy the cryptocurrency, that's a block. That's a transaction. And then you take it to using that cryptocurrency to buy something on the blockchain, then that's a transaction. So, and so forth and so forth, and you're constantly making transactions on that blockchain, it's going to constantly keep growing. So but what's on the blockchain is our data. This is the important thing about our community, and one thing we have to figure out, or really not figure, well, kind of coming to the understanding of that everything already has data on it, or everything already has a database, and we use data every day. And these things are used in a sense to record us in our history. Like with Facebook, you can go, years back in time with posts or whatever and stuff like that. But that database is centralized. If such and such Mark Zuckerberg, whoever owned it, destroy it or take it out or whatever, we really can't do nothing about that data and those pictures and all those things or whatever. Back in the day, it was a photo book. Our parents and all that stuff. My mom and them still got photo books and tapes or whatever and stuff. So, like, it's, that stuff even goes out or whatever because it's the whole function of it. But with this technology, you can literally go back to this data because it's the same data, and data really, the data doesn't die as long as you have the hardware to put it on there and stuff. And what was that? I think it was last year. They are coming up with ways to put data on crystals. Like, so if you think about, okay, and this data on crystals can last for Yeah, so here we go. Yeah, data can be stored on crystal using 5D memory crystal, which is a data storage format that can preserve information for billions of years. Like this stuff, there's some the technology and the things that's going on is it's crazy what's going on nowadays. So if you think about, okay, we have a blockchain that's on, we have nodes that their database is this right here, or their storage is this type of memory, 5D crystal memory. That storage unit or that database in that computer, it will last forever. Long once they take it out or whatever and put it in another computer, they'll be able to see it. So, 200 years from now, 500 years from now, if you made a picture and it was on a blockchain, your great 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 grandchildren will be able to see that. And that's why the importance of the blockchain with the time of it, everything already has a record. Everything already has the data aspect to it. But by putting it on the blockchain, one, it gives us ownership of it because whatever data you put on with that, you have an account on the blockchain which has that public and private key. Someone had talked about it, or we was talking about it in a discussion today. I was helping the person out understand a little bit because they was kind of mixing up the hash, the cryptographic hash for the block, and the public and private key hash. So the public and private key is a hash. It's the public and private key is the words or whatever. What will make those words is behind a hash. So yeah, that is a hash, but that hash is not the same thing as the block hash, which how the nodes read the blockchain. So the public and private key, long as you have that public and private, or you have that private key, you can put that wallet or that account on any type of wallet service that they have. As long as that they have the NPC, what it's called, the RPC remote. Yeah, where is it at? So how these nodes connect to a block. Where is it? Yeah, okay. So how the nodes connect to a block is through a RPC call. So yeah, so set the node key, a verify session key setup, or whatever. Where is it? There's another piece. All right, never mind, forget it. But that's the RPC is a remote. I think it's what's that protocol or whatever procedure call or something like that. I can't remember the exact words for it. But basically, this is how a wallet, like with MetaMask, how a MetaMask wallet connects. So, say if I want to add a custom network to, let's go to chain list. So these right here are a different blockchain, and this is right here the RPC, the basically to connect to these blockchains. So when you're on MetaMask, to add those on there, how these different networks right here, you do the RPC URL. So you put the network name, the chain ID, the currency, the symbol, or whatever, and then also you can put the block explorer. But this is how you connect your wallet. So when you have your private key, you can take that private key and put it on any one of these wallet services. Now the private key or the wallet service might not have like for instance, some aren't compatible. Some of these blockchains aren't compatible with certain wallet services or whatever. Like I think what was that? Binance when it first came out, you couldn't put it on MetaMask, I believe. I'm not sure if not, but it's certain. They only have their wallet, and like certain blockchains only connect to their wallet that they created. It's like certain procedures or whatever, security and things like that. But the whole aspect of it, once you have your private key and you upload data on that private key, and that blockchain, that data is put onto that blockchain, you will always be able to access that data. So a picture from right now can last 1,000,000 years, or almost 1,000,000 years, but yeah, damn near basically with the technology they creating and what things is going to. But everything, like I said, I said this years ago, everything is going to be on the blockchain because the technology is way better, is more efficient, and then how the videos, what's that? Oh no, that's not it. Hold on. Oh no, IPF, interplanetary. Yeah, IPF, interplanetary family system. Yeah. So this right here is how you will upload videos. This is a service what developers use when you upload it. Oh no, that's not it. That's definitely not it. Okay, I'm tripping right here. So this right here is how when you build a blockchain website, how you can actually access it on the block. So you can actually put all the code, everything, all of it on the blockchain, where then no one can take it off. This is what they're talking about. This is one of the reasons why, like TikTok, Facebook, all these different platforms, they don't want people really to be involved into these type of platforms, these blockchain websites of social DAOs or all that type of stuff. They have dApps. Let me show y'all real quick. They have social blockchain. Like think about if all our people, a bunch of people just was on these different blockchains. These blockchains have money and resource on it where you actually, just the everyday people, you get money on it. And now you can with Facebook and all that type of stuff, you have to get certain followers and all that type of stuff, and they really be hustling. Because for instance, I'm gonna tell y'all something. The Hillman Talk hashtag, I know for sure they putting a limit on that. They're not finna let that traffic, because you got to think about it. These platforms make money off of selling traffic. So that's why you can have 20,000 followers and only 300 video views on a video, because they trying to get you to pay for the actual views. And if a Joe Blow like me or anybody, this everyday person, can hop on there and all of their people, every person that they can actually follow them, see their posts, then it will be no purpose for them to actually charge businesses to get traffic. They can just literally go to a random person or do little affiliate services or programs with the people, whatever, or bonuses or whatever type thing, systems where, hey, if you upload this post or whatever, I give you free food for a year. If you got 100,000 followers or whatever and stuff, simple things like that. I'll pay you some money. So it takes them out of the position. The social networks, the traffic is the whole thing. They're not going to let that traffic go so far, because they make money off of that. And if any hashtag is created organically, especially dealing with our people, you will see it go up, and then you'll slowly see it, like, it's not really like drops drastically, but it's like it's a ceiling, it's a glass ceiling, and they do this on every platform. It never fails. You can literally watch a trend grow. Like, I've been doing marketing for years, digital marketing for years, and so I understand how this stuff works and basically how the system works. But you can see a trend grow, and then at a certain point, it slowly starts to die, and then it stays, like, it doesn't get past a certain point. And that's really because, like I said, in the algorithm, they're going to smut it. They're going to put it a certain down or whatever. And then also, one of the things I think they're doing with, we built this movement up, and then the traffic was going to that TikTok university. So TikTok obviously that's their hashtag. They're gonna run with that and keep that mug flowing, and it's just business. It's But when we understand, okay, this is business. We really are the resource that gets them their money, and they take majority of the money home. But if there were social media platforms that's on the blockchain, like these ones right here, like, it's all kind of different platforms. If you hop on these platforms, post videos, post content and stuff like that, it automatically generates money just by the transactions. And then when advertisers put money into it, these platforms now have the same resources to do the same thing that they're supposedly, that's Facebook and TikTok and all these other platforms supposedly doing. Now, the only one I really see that's kind of doing really good with the traffic and paying people, I heard, is YouTube and seeing a little stuff. But the other ones, you got to have so many followers and build up so much stuff, and it's more of a scam, because they push you to post this stuff, and then you can have all your followers is not gonna see all your content. So it's like, what's the point of me having these followers? It's just really to hype people up, and because they want you to pay for those followers that you already have to see your stuff, because it makes them money. They not finna, that's the whole hustle with the social media. So a lot of the stuff with this blockchain technology, the reason that you don't see, like, for instance, with what they call that, the App Store, the reason you don't see the what the certain apps or dApps on the App Store is because them people, they not gonna make money off of them apps. You can set up a dApp and people can come straight to your thing, pay with cryptocurrency, and never pay the App Store. And the App Store make 30%. They literally make every time you buy something from the app that you have on your phone, they're literally making 30% off of every transaction. So they want everybody to come to their stores. So anything that's saying, hey, we don't want y'all to be a central power to us. We want to be able to build our own things or have, systems where the money that's going into it comes back out to people and comes back out to the community and stuff like that. They not finna let that go. They finna fight tooth and nail for that stuff. And that's one of the reasons why in America, a lot of these platforms and these dApps and all that type of stuff over in other countries, they rock with them because it's just certain aspects. Like in Brazil, they need certain mediums or whatever where it's they don't have to use the government money, and their money ain't that valuable right now, but they have a freedom or whatever because they see, okay, we can build things like this. I think it was this one right here. I think this was it's like some Indian social network, and they've been paying people like this. They've been paying people for, what was that? I think back in 2020 when this first popped out or whatever, they had been paying people or whatever. And you can see what's that within 24 hours. This how much money that's been circulating on that platform, and you can watch the resources. So that's the thing about it. Like when you understand the technology and you see you can go to the smart contracts and see what's going on, it's hard for people, the central powers, to take control and take your money and stuff. But in this world or whatever, and in our world, what we dealing with, yeah, they it's like that red note. People seeing what was going on that app and how they really be kind of like blocking stuff, and people really don't understand. In America, they block a lot of things that we do and a lot of things that we see because this stuff right here is ridiculous. It's like all these apps, and these people been doing this stuff for a while now. They got all these different systems or whatever, social networks, and let's see, I ain't never seen what this one right here was. MetaWin. Oh, okay, it's like a, oh, okay, it's like a little lottery thing. It's probably like these little games you be playing on, people be playing on their phones where they win a little money or whatever. But this one right here, these ones you can actually see the money going. You see the people getting the money. You probably can go to these blocks and see that. Let me see. Oh no, I gotta connect. I ain't trying to. Oh, that's a game that's paying out the change or whatever in the amounts. Okay. Yeah, I'm gonna do a little research about this one tonight. See this one is. This is one reason why I stopped dealing with some of the blockchain dApps or whatever, because you'll be in this stuff all day, and it's so much opportunity. And oh, hold on, a nerd club. Okay. So hey, this is a way right here, easy way to make some money. You'll see a lot of these things like this, where you can learn and earn. There's a lot of these, like other than Coinbase, they try to, they do the pay for play and all that stuff, or they, try to give you some money for doing it, some learning and stuff like that. Oh yeah, my Discord is Discord link is in the bio. All right, y'all. I appreciate all the likes and all that type of stuff. I'm gonna keep it going for a little bit more, but what was it? I think we kind of went over everything, like the history, consensus, cypherpunks. Talked about that a little bit more than I wanted to. But yeah, that's everything we went over and stuff. Yep. And then the energy trades off and all that type of stuff. All right. But yeah, so yeah. Also, I'm gonna make some videos about these nodes. Y'all interested in learning about those? So you can actually create a node, and basically a node is basically just your computer. You set that computer to a side where it basically just solves, algorithms. So let me see. You gotta run a lot of scripts and do a lot of scripting on there. Appreciate all the likes and the gifts and everything, y'all. Thank y'all. What else? Oh yeah, running out. Yeah. Okay, yeah. So yeah, I'm gonna talk about these right here. So basically, a node is basically a computer you just got to set up, and you download the blockchain on it. You see right here. So validators, types of nodes on the core network. So now this is a core network. I don't even know what the blockchain that is. Probably called core, but yeah, core block. But anyway, so role validators are crucial for securing the network by producing blocks and validating transactions within the core chain consensus framework. Requirement validators need to stake minimum of 10,000 core tokens. All right, so let's see. And y'all, this is not financial advice, so I don't want y'all to take any of this as financial advice and be like, okay, he trying to, he trying to show us how to make some. He trying to tell us how to spend our money. No, I'm not doing none of that. I ain't telling you where to go, where not to go. Alrighty, core to USD. Oh wait, that don't even like the same one. Oh, you know what? Let me just type in. Yeah. Okay, 72 cents for core. So how much is that? About like $7 grand or something like that. Okay, Coinbase, that's what's up. Alright, so we got, what did I say, 10,000 core tokens? Oh, hold on. How much is one core? This is the same, it might not even be the same core. Let's see what that tick is. What this, But anyway, it's basically, so 10,000 core tokens to participate, aligning their financial incentives with the network performance and security. So this is like a proof of stake version right here. So I can just tell by when it says you have to stake a minimum amount, that's a proof of stake. So the validators requirements is C4. Let's see, normal node. Okay, that's a validator node. See, normal full node, run a node maintained to complete real-time copy and blockchain ledger validation transaction and support network by relying blocking transaction data. These are essential useful for private. Okay, so this, I think this might be, I know it's a hybrid definitely, because it's like it's a validation right here. Or it might be, let me shut up, I don't think it might not be a hybrid or whatever. Application program interface. Okay, the RPC. Now this is where they put their dApps at on here. Important, they are essential for the development and operation of decentralized apps. Okay. So this node right here, and it's definitely advancing. A lot more different blockchains advances. I done been playing around with this stuff. So let's see what this. So this right here is Polkadot. Let's see. Let me close these other ones. So let me look at that Solana. I know some people be interested in looking at Solana. Well, yeah, I guess the blockchain could tell me where the nodes at. RPC, APN. Let me just try. I guess do. You might not need. Some of them you can't even set up nodes. Like you gotta. They have proof of reputation, so you gotta be, a certain level for them to. See, Solana nodes are probably. Make sure I'm going to the right one. Somebody talking about it versus. Yeah, okay. Alright, so this Solana website, yeah. So become a validator. And yeah, so this right here, when you have a script and you solve the hash or the block hash, and however the consensus is set up on these different blocks, this is how a lot of people make money. So you get rewards based on the validator. And the validator or the node is basically just a computer that just sits in a corner somewhere, and it runs the scripts, and it saves the blockchain ledger on it, and that's basically what a validator is. Now there is aspects of programming and coding and things you're gonna have to do when you get involved with it. So it's not something that's just simple like, oh, I can just easily do this. You will have to do some developing and all that type of stuff, and really understand what you're doing, because like I said, it's, you got to solve it. So to solve these hashes, you have to actually create code and scripts and things like that. So it's not something you can just kind of you know, just download the computer, download the ledger, and run it on the wing. And also, especially if it's one where you staking stuff, if you staking resources and things like that, yeah, you can lose money very quick if you don't know what you're doing, and you don't want to lose money. Well, I don't even want to. I don't want to tell you, because that's financial advice. So I'm not gonna tell you the ones I be getting into. I'm gonna say that for later in like the Discord, when I do some like solo Discord post or whatever and stuff, or solo Discord lives. Because when you do it on YouTube and TikTok and all these other platforms, they be tripping. So, but yeah, so let's see. Staking, stake pools. Okay, here we go to doc requirements. Okay, so see, they tell you it's literally like, if you ever had any computer games, this look familiar to you. Yeah, you gotta have so much RAM, so much compute power, so many disks. And obviously, well, you don't need the graphics core, but obviously graphics core would be good. Run validated for live cluster include mainnet beta. Inside Docker tab, the general not supported. This is the concern of general Docker containerization overhead and resulting perform integration unless specific configured. We use Docker only for development purposes. Okay. Alright. There goes command for yeah. So it's CLI stand for command line. That's let me show y'all real quick. That's this part right here. You're running command lines in that little section. That's what these little things right here. But first, in order for you to do any of this, deploying the Solana program, you're going to actually have to install. So you got to install this right here. It's Solana CLI. And you have to do this with every blockchain. So it's like basically like the SDK. But, I just want to show y'all this. I'm just kind of just getting it. This is what I do all night, so y'all getting kind of sneak peek of this. I'm actually gonna be doing some testing out with the cursor tonight. So after I get off this TikTok live, if y'all want to watch or stay connected and keep going with us or whatever, I'm gonna be in the Discord, and I'm gonna let y'all watch me do some coding with the cursor and some AI. Really trying to get this AI figured out, get it kind of trying to speed up this workflow, you know. I'm trying to spend hours and days. Then also be getting caught up with the fun of it too. Because when you start building stuff and you start solving and figuring it out, it's just a whole nother world. But let's see, yeah. But yeah, so that's the nodes in a nutshell, somewhat. Basically, so the nodes, like I said, it's a computer, and you can actually make a lot of money off of this. Let me see where Here it is. Okay, no, we're not talking about stakers. Yeah. This is another same thing right here. This little section, they be trying to get you to stake your tokens or whatever so you can use it. I mean, if you don't really have too many the cryptocurrency to stake it and to kind of make some money, and or even if you got a lot, but if you have a lot and you have some money to spare, I mean, not spare, but really money and invest, you want to get a node. I just want to give y'all love. Okay, yeah, small validator with 1,000 Solana stake may average earn 55 to 60 Solana annually, which is currently estimated at 13,000 to 14 annual. Okay, and yeah, and this basically the validator or a validator is a node. So this is a computer sitting in the corner of your house earning you 13 to 14,000. And if you have, you know, but also it's other aspects to it too. So I don't want to be saying stuff like, you know, you can make this much money because there's the energy price you have to pay for this, the time you're gonna have to spend also making sure everything work right, and all the scripts run right, and then also with code, things get updated and different versions of code come out. So if you're using certain tools or services, you might have to do, you know, you're gonna have to obviously do a maintenance on your code and software all the time. But yeah, but all right, y'all. So I think that kind of sums it up for today. We went a little bit over. Hey, y'all, put some feedback. Tell me how y'all think I did with this. I want to get some feedback. Really, I'm really trying to get better at this teaching stuff and actually do better lives or whatever and stuff like that. Yeah, bro, you missed everything, bro. I'm just playing with you, but yeah, don't worry about it, man. I saved. Yeah, we about to end. I saved everything, so you can go to the YouTube and check it out and everything like that. So yeah, that's I save all these classes, so if you ever miss any of these classes, you can go to the YouTube and check them out and stuff like that. But yeah, so we went over today. I'm gonna do a recap again over when I post, but we basically went over the consensus mechanism, hashing algorithms, cryptograph history, cypherpunks. Yeah, that's kind of went over all that stuff. And I'm like I said, I'm gonna make another video. But also, yeah, give me tell me how I did. You know, I don't mind constructive criticism. Shit, I don't mind if you don't like it. If you don't like it, just tell me that too. I'm gonna rock with it either way. But if y'all can give me some tips or whatever pointers, what you think I might need to work on better. I know for sure with how I'm setting up with this internet, because I don't know if there's lag in you know, how everything flowed or whatever, because I'm not seeing what y'all seeing. And also, it's a different experience talking to a computer. Ain't nobody in here. I'm just talking to myself. It's weird, you know. Still trying to get used to this live and all that type of stuff. Appreciate it, Tish. Appreciate it. Oh, thank you. I appreciate everybody that joined. All the supporters. My bad if I missed this Discord chat. If y'all was saying something in the Discord chat, let's pull that up. Okay, y'all good in here. Appreciate y'all for joining, tuning in. Like I said, I'm gonna post some node information in there, like how these validators work a little bit more. Breakdown. I'm gonna do some highlights of some simple nodes that you can set up and earn some passive income. That's gonna be like some earn your money, earn money or whatever, like bonus type of post or whatever. But yeah, that's it, y'all, for the night. I'm gonna hop on here and probably do some coding before I get too tired with my coffee here, cause I don't wanna be up all night. Alright, that's one thing I forgot. Okay, I got enough time to run through the stuff. Alright, y'all take it easy. I appreciate y'all very much for joining, the support, the hearts, the likes. We didn't get up. We got we got what's that, 11,000? I'll take it. I appreciate it. I appreciate it. That's more than I ever got. I ain't never got that many likes on the post, but or alive or whatever. I'm just getting used to the stuff. But yeah, I appreciate y'all. Y'all take it easy. Yeah, tune in. So we're gonna be back here Monday, 7 p.m. It's gonna be lesson 3, and then next Thursday too. So next month, this Monday coming up, and Thursday coming up, we're gonna be getting back on it. I'm gonna be hopping on here live and posting some more stuff. Also be posting videos. Also, I'm gonna do some more little bonus lessons and things like that, and probably some recaps or whatever. Also, I'm gonna have y'all come on here and talk to me and ask me questions what y'all want to learn. That's the next thing. That's probably my next live I'm gonna do. Ask me anything, where y'all can actually hop on here and just talk about it. We can discuss blockchain and all that stuff like that. But yeah, alright, y'all take it easy. I appreciate y'all. Log out this TikTok. I'm probably gonna stay in the Discord for a little bit. I'm gonna check out what this